Hi, welcome to the Mastercam 5th axis programming session. So in this session I will teach you some 5th axis of toolpath. So let's start. We will go to the toolpath tab. So here you will get multi-axis toolpath options. So in this strategy you will get many options like for pattern finishing, and you will get some application for profile finishing. So first of all I will show you that how we can convert 2D toolpath into 5th axis toolpath. So first of all I will create a 2D toolpath by following this curve, and then we will convert that 2D toolpath into 5th axis toolpath. So let's start. So first we will create 2D toolpath. So here I will take a contour toolpath, and I will select wireframe mode, and I will select this curve, and then say OK. And then I will take the tool. I will take this tool, 30 mm ball and mill, like this, and I will use this holder, this type of holder for 5th axis machining. And then I will take I will use cut parameter, and I will keep compensation off, and we don't need depth of cut. We will go to the linking parameter, and also we don't need lead in out. We will go to the linking parameter, and here we will say top of stock incremental and depth also incremental, and then say OK. So as you can see this is the 2D toolpath, but if I will show you the back plot, then you will understand that how it is working. So I will play it. So as you can see now this tool following this curve, and as you can see there is a taper profile, right? So we will check that. There may be a chances of collision or gouges. Your tool will gouge with that wall. So you can see that tool gouging with that wall. So it will cut that profile if we will use 2D toolpath, right? So I will show you that how easily we can convert 2D toolpath into 5th axis toolpath. So here we will deactivate that, and here you will get a convert to 5 axis toolpath. So you can convert this 2D program into 5th axis program. So I will select here convert to 5 axis, and then here I will select the same tool, and here I will say toolpath to 5 axis. So I have to convert it into 5 axis. So I will select that, and here you have to select the input toolpath. Here we will select that, and here we will select contour toolpath, which we have done previously. So we have to convert this 2D toolpath into 5th axis toolpath, then say OK. Right, here you don't have to change everything. You can give the tolerance and all, and linking we will say links from input toolpath, and tool axis control we will say here we need not 3 axis, not 4 axis, we need 5 axis continuous toolpath, and maximum angle step that will be 3 degree. Fine. Tool axis control we can give from point. So here I will select the point. So you can see I have already created a point, so I will select that. So our tool will move from that point to this point, and here I will say collision control. Here I will define the check surfaces. So I will define this surface, this one, and this one, because we have to avoid this surface from collision. So it will understand that we have to avoid this area. So here you can say check fluid, check solder, check shank. So here you can see these all are the red areas. So software will understand that we have to avoid collision and gouges from all these areas, right? So next you can say linking parameter. Here you can click that. Here you will get type of plane. So we will say we need clearance by plane. You can keep it default. Height you can define as per your job height. You can make it to 200 or 100 as per your job height, and then here we will not do anything, and then say okay. So now we will check that. Let's play it. Okay. So now it is moving like this, right? So you can see now this tool moving continuously, right? So now now the same 2D toolpath converted into fifth axis simultaneous toolpath. So your tool will not goes with that area, because now it has been converted into fifth axis toolpath. So now there will be not any collision or gouges. Now your wall will be safe. So easily we can convert 2D toolpath into fifth axis toolpath. So you can see how it is tilting in that area. So every time your tool will tilt with that area, and it will avoid the gouges and collision very easily. Okay, so it was convert to 5 axis. So next one I will show you, that is roughing toolpath for this area. So how we can create a pocketing toolpath by using fifth axis strategy. So I will go to the multi-axis toolpath, and here I will say pocketing. I will select that. We have to do roughing up this area. So I will select 10 mm of flat end mill, and here I will say cut pattern. Cut pattern, I will select the part surface first. So this is the part surface. Okay, and then we will select the floor surface. This is the floor, and then here you can say machining type by roughing strategy, offset from floor, type dynamic or offset. You can make it as per your requirement. You can change that, and here cutting method one way or zigzag, you can change that here, and cut tolerance you can make it here 0.5, and step over 50% of the tool. So it is 10 mm, so I will make it 5 mm step over, and here you can define the depth of cut. I will say 0.5 mm of depth of cut, and then say tool axis control. We don't have to do anything here. Linking, you can say direct, so it will create direct passes, and then say okay. So now it is showing stock definition is missing. Okay. We will go to the parameter tab again. So I think we forgot something. So okay, so we will deactivate this option, so it will not ask dynamic holder collision. Okay. So we have to deactivate. No, we have already defined the holders and all. Tool holder. Okay, fine. Cut parameter. So these are the things that's looking good. Tool axis control, linking parameter, so it is also looking good. Depth spread, that is also looking good. Dynamic holder collision avoidance with in process stock can't be used without stock defined. Okay. Let's check it. So you can say use selected geometry, but we did not define. We can say job setup. Okay, let's try. Stock definition is missing. These all things are looking good. depth spirit collision checking, we will deactivate this option, and then let's check how it is. Okay, so now we will do roughing for this area. We will create a roughing program for this area by using Mastercam multi-axis roughing toolpath. So we will go to the multi-axis roughing toolpath. Here we will select pocketing, and then we will select the surfaces and all. So now you can see, first we will define the tool. So we will use 10 mm of flat end mill for roughing this area, and here we have used this holder. Okay, fine. And then next we don't have to use stock and all, we have to create simple roughing toolpath. We will deactivate that, and here you can define the cut pattern. So first of all, we have to define part surfaces. So I will double click on this surface, and I will deactivate this one, and then say okay. And then you have to define floor surface. So this is the floor surface, and then say end selection. And here you can define the machining pattern, roughing strategy, offset from floor, type dynamic or pocket, offset you can select as per your requirement. I will say dynamic, and here you can give the maximum step over. So I am using 10 mm of end mill, so I will say step over 5 mm. And then here I will say depth of cut, I will say 2 mm, because we are using dynamic toolpath. So we will go to the tool axis control. We don't have to check collision in that area. Linking, we will keep the linking as it is. You can customize the rapid distance and all. So I will customize that 1 mm and 1 mm, and these all things looking okay. And then we will say okay. So now it is processing. So you can see this is the complete roughing toolpath for this cavity, right? I will play that, and I will start from here. So you can see this is complete dynamic motion roughing toolpath. So it is moving in that area. So you can create a roughing toolpaths by using the Mastercam 5-axis pocket roughing toolpath for all these areas. Okay. So the next one I will show you how we can create a finishing program for this wall, or I will show you the same toolpath how we can use for this area finishing toolpath. So I will use swarf milling toolpath, that is 5-axis swarf milling toolpath. So I will click on that. I will use 10 mm of flat end mill, and I will go to the cut pattern. Here I will define the swarf surfaces. So I will click the shift key in the keyboard and I will say OK. So it will select all the surfaces in one time, and here you can define the curves, upper rail and lower rail, but I will leave it for now. We don't need that. Output format we need in 5-axis. Here gauge check, we don't need that. Linking parameter, I will say small gap size 100%, so your tool will not retract every time. Here you can say automatic clearance type, and the next one is multi cuts. So if you need multi cuts you can give here, but I will finish that area in one time, so I will not give any things here. And here you can give the planes. We have to do machining in front area. Okay, and then say OK. So now you can see the tool path has been generated in 5-axis swarf milling tool path. So I will show you the backplot now. I will say play. So you can see it is moving continuously, and this is complete simultaneous tool path. So your tool will move by following the surface angle. Perfect. So we have done finishing in one time. So if you want multiple cuts, so you can give that. There is an option, I will show you. There is a option for multi cuts. So here I will say by slice distance, I will give 1 mm of depth of cut, and then I will say OK, and then I will regenerate that. So you will get some multi passes. You can see like this, you will get multi passes. So you can create the multi passes also if you need. I will deactivate that. I will activate the backplot, and I will play that again. So like this you can create these all profiles toolpath by using swarf milling toolpath. And all the things, I think these all things are possible in 3-axis milling toolpath, because this all area is flat, and this all area is possible in 3D toolpaths. Okay,